Syllabus directly? You had a look?
Yeah.
Pehle, just let's understand the basic concept that what are we trying to do in this. Okay. So you studied the chapter of EM waves, right?
Yeah.
And there what you're taught is that all these are electromagnetic waves, right?
Sure. Yeah.
But the reality is the EM waves, including light,
Mm.
the visible part of the spectrum, exhibits two behaviors. One is wave, the second is particle.
Particle.
And
Yeah.
therefore, we say that the radiations, which are electromagnetic radiation, light, sunlight is an example of electromagnetic radiation, exhibits both the wave and
Wave and
particle-like
particle.
properties.
Yes.
This is the basic cornerstone of this chapter, that even if you look at light, you will say that light is behaving in both the manners.
Yeah.
Okay? Or
Yeah.
any electromagnetic wave for that matter, ultraviolet, X-ray, anything is also having a particle-like property. Okay. So when we say the waves or the radiation or the EM radiation, when I say radiation, I mean X-ray, etc., everything.
ठीक है.
Okay, has a wave nature. So in the chapter of wave optics, we studied interference,
Yes.
diffraction, and polarization.
Yeah.
We studied two types of interference. We studied one type of diffraction. We studied three types of polarizations, right? Malus law for this reflection and for the absorption, Brewster law, etc. Right? Now, those three behaviors of light, the phenomena of interference, the phenomena of diffraction, and the phenomena of polarization, what they tell us is that the radiations are waves, because interference, diffraction, and polarization are typical behaviors of a wave.
Wave,
So
yes.
all these three phenomena are an excellent example of the fact that all the radiations or the EM waves are wave. They prove it. Okay. So now since it is a wave, it will have a wavelength, lambda, it will have a frequency, it will have a velocity. Because these are general aspects of any wave, right? It can be sound wave also, it can be radiation also.
Right, yes.
So when I say radiation, typically I mean EM wave, okay? Now, the second thing is the particle nature of the radiation. Now, what does it mean that radiations have particle nature? So what it means is that the particle behavior of the radiation, the evidence was the photoelectric effect.
Okay.
There are other effects also, but they are out of our syllabus. One effect which is not exactly out of our syllabus, but a class 11th concept, is a black body radiation.
वो chemistry में किया है. Yes.
So if you say radiation is a particle, then you are saying that the proof is the photoelectric effect happens and the black body radiation happens. We don't need to study black body radiation. We are only going to concentrate on the photoelectric effect to emphasize the particle nature of radiation. Right? And when we say the particle nature of the radiation, what we say is primarily, which we will study in detail in the photoelectric effect itself, that light is also a radiation. The big word is for everything is radiation, includes everything.
Okay.
Light is made up of discrete packets called as photons.
Yeah.
Right? So every photon has an energy which is equal to E is equal to h nu.
Yes. Yeah.
H is the Planck's constant and mu is the frequency of the radiation or light. Right? So so every radiation has two things. So a radiation has dual nature. It exhibits wave-like
And particle.
Like, right?
Yeah,
So
yeah.
we are going to study primarily because we've already done interference, diffraction, and etc. So we just need to know that what are the evidences of radiation behaving like a wave. Radiation behaves like a wave by the experiments of interference, diffraction, polarization.
Yeah.
Our radiation behaves like particle by the experiment of photoelectric effect.
Photoelectric effect,
It is made
yes.
up of photons, photon energy, so and so. Kata.
Yeah, yeah.
Right? So, okay, we have to, however, understand that it does not mean that light or a radiation together simultaneously exhibits the properties of wave and particle. It does not mean that.
Okay.
It exhibits the property of either, but the choice of saying that it is particle at this time or a wave at this time is contextual. What's happening in that situation will decide, and then we will label the radiation as a wave or a particle.
Okay.
No radiation exhibits both the behavior simultaneously.
Yeah.
One at a time.
Yeah.
If an interference is happening, you will not be able to say it's a particle behavior also. No.
Yeah, yeah.
At that time, it is exhibiting wave.
Wave, yes.
Right? So you should know that. Okay. Then, if somebody says, okay, what are the what are the practical implications? Okay, of this understanding? What do we make out of this? So, for example, what you make out of this is photoelectric effect, which is an evidence, has a practical implication.
Achha. Yeah.
Photoelectric effect is a clear-cut experiment done by whosoever he did, Einstein, right? Now, but what is the use? Photoelectric effect was able to make us understand that when light or radiation strikes the electrons on a metallic surface, right? The energy of the emitted electron depends on the frequency of the light, not its intensity.
Frequency of light.
Yes. So the energy of the electron that comes out, because the photon strikes the packet of energy strikes the metallic surface.
Yeah.
That electron now which comes out, its energy is not decided by the intensity. Intensity means the number of photons striking per second. It does not depend on that, the energy of the electron or the photoelectron or the emitted electron.
Achha.
So we are getting in slightly into photoelectric effect at broad level.
Frequency like हर point पे same नहीं रहती है?
नहीं. The emitted electron which comes out from the metal after the photon strikes it, its energy, kinetic energy, is not dependent on the number of photons.
Okay.
It depends on what was the frequency of the radiation.
अच्छा, ठीक है.
If you strike a metallic surface with 100 photons, that will not fetch you electrons. You will not be able to eject electrons from a metal surface. And so you have to increase the frequency. After a certain frequency called as a threshold frequency, the electrons will come out, and the balance of the energy of the photon will go towards the kinetic energy.
Okay.
Right? So intensity is unimportant. So practical implication in detail we will study. Photoelectric effect, we will study. The implication of photoelectric effect is that we were able to understand how photoelectrons come out of a metallic surface. And this emission of photoelectrons from a metal surface when struck by a radiation is not dependent on the intensity of the light, but it is dependent on frequency of light. Or radiation, whatever word suits you. Right? We don't need to get into details of diffraction and interference to demonstrate the wave property of radiation because we've already studied that. We've studied that light is capable of creating patterns, maxima and minima, or thick fringe and small fringe intensity. After that, because of superposition
Yeah, right.
from one slit or two slits.
Huh.
Right? So if somebody says, what are the practical implications of learning photoelectric effect? Why do you learn it? Okay, so radiation is a wave. Understood.
Yeah.
Interference, diffraction. Radiation is a particle-like. And you said photoelectric effect is an evidence. Okay.
Yeah.
So why do we study photoelectric effect? What was so big about photoelectric? What is the practical implication of photoelectric effect, right? Then you explain the photoelectric effect.
Okay.
That ejected electrons from a metal surface are completely dependent on energy of the emitted electrons.
Yeah.
Right? The energy of emitted electrons is going to depend only on the frequency of radiation which struck the metal surface.
Yeah, right.
And when I say radiation struck, I mean photons struck of that frequency.
Okay.
It does not depend on how many photons come. Some people will say, I will put 10 photons of small frequency.
Acha.
You will not be able to get any electron out. So taking the electron out also needs a certain level of energy.
Yeah.
Now, this level of energy is called as work function
Acha.
of the metal. Sodium has a different work. So you send a photon of good frequency, you're able to take out the electron. So some part of energy is gone.
Oh, yeah.
To overcome the work function of the metal.
Acha.
The balance energy goes towards the kinetic energy of the electron.
Acha, ठीक है. Right.
So you have 10 rupees, 5 rupees go towards taking out the, the thing you bought from the shop. The balance 5 rupees is the courier cost.
Acha.
5 plus 5 is 10, right?
Yeah,
So
yeah.
you want to take out the electron, spend the money called as work function. The balance money is to be used for the purpose of giving kinetic energy to the extracted electron, and then it runs.
Yeah.
Right? So this is called as the photoelectric effect. We will study this in detail with maths, reasoning, and all of that. Okay? Now, the second part of the chapter is, okay, so that means only radiations have dual nature. A radiation has a wave-like nature, and a radiation has a particle-like behavior.
Yes.
What about matter? So matter and radiation is being studied, right? So somebody said, okay, matter. Give an example of matter. Electron.
Yes.
It has a mass. It has right. So we will not study, although everything is a matter, but we will study the subatomic subatomic level, right? Very small masses. So electron also exhibits. So you think electron is a particle, but the dual nature says that electron is also a wave.
Acha. Okay.
Right? Who said this? There was a scientist called as D. Broglie.
Acha. Okay.
D. Broglie said, what you call as a particle is actually a wave. So he had his own hypothesis called as a D. Broglie hypothesis. You have to study in this chapter detail photoelectric effect, which is all about the particle nature of radiation.
Yes.
Wave nature you have already studied with the help of diffraction, interference, etc. You don't need to study it again. Now you will study the wave nature of the radiation, and then you will also study the wave nature of the particle.
Right.
Right? So sorry, you will study the particle nature of the radiation with the help of photoelectric effect.
Yeah.
Okay? And you will study the wave nature of particle.
Yes.
That's the end of this chapter. If you understand photoelectric effect and then you understand D. Broglie, you're done. You have learned the chapter nicely.
Okay.
So the two basic concepts in this chapter, photoelectric effect slightly lengthier to explain. Some maths and some formulas, two formulas, and D. Broglie is only one formula and one concept. That's all.
Acha.
Got it?
Yeah.
So let's now, you know what is a photoelectric effect? You have a sense, at least, that it is an evidence to show that the radiations are particles. These particles are actually the photons. The theory is that the particle is nothing but the photon, the packet of energy. Right?
Yeah.
So let's elaborate on the photoelectric effect now. Okay, I'm just discussing it with you. Once you have a clarity in your mind, then we will study the maths of it. Right? Then we will start writing and all that, right? All right. So let's come to the key observations of the experiment which was done. Okay.
Yeah.
So what they did was they took a metal. The scientist is Hertz.
Acha.
Okay. So what he did was he took a metal, he exposed it to a light.
Acha.
And what he found was that something is happening, and the explanation of whatever was happening was given by Einstein.
Okay.
Right? So Hertz exposed the light on the metal and the observed something, but the justification as to what exactly is, why is this happening,
was
given by Albert Einstein.
Okay.
There was a gap of many years before this was done. All right. Now let's come to the key points of the photoelectric effect. What are the key observations in the experiment? One was that there, if you expose a metallic surface to light, not all lights were successful in giving you electron emission or ejection. They failed. Only when the light was of a minimum frequency called as a threshold frequency, which means your energy h nu was of a certain level, the photon energy, were you able to get electrons out. Otherwise, you could have hundreds of electrons stacking, but if this minimum frequency is not provided, no emission would be noted.
Okay.
This was one.
Yeah.
The second observation was, and each of them result in 1 markers and reasoning questions and reasoning assertion questions. So you have to know the observations of photoelectric effect very clearly. Okay. Second, instantaneous emission. What they found was as soon as the light strikes, immediately the off frequency above the threshold frequency or the threshold frequency minimum, the electrons come out immediately. There is no delay. It doesn't take time gap. Okay. We will come to this. What does it mean?
Okay.
Threshold frequency. It is the frequency, minimum frequency required, regardless of intensity, regardless of number of photons you strike. It is the minimum frequency required for the emission of electron. This is actually the central part of the photoelectric effect. Okay. What is the effect of frequency? If you increase the frequency, because now the frequency is above the threshold frequency, you are successful in emitting the electron. And the extra energy will go to the kinetic energy of the, right? Common sense. But what photoelectric effect says is, this observation becomes what? That the kinetic energy of the electrons is a function of the frequency, not intensity. Some people try to do experiment by they said we will put a lot of energy by using 100 photons. They still could not get the electrons out. If you have one photon whose energy is more than the threshold energy, or the frequency is more than the threshold frequency, you were successful.
Okay.
So it is not the number of photons that decide whether the electron will come out or not. It is the frequency of those photons.
Yes.
Okay. Now, somebody said, okay, then what is the role of intensity? I said, okay, it does play a role. First, increase the frequency to minimum, which is the threshold frequency, to be successful. Now, intensity can play an important role. How? If you have 100 photons of good frequency, which is more than threshold frequency, you will be able to get 100 electrons out. One photon can emit only one electron.
One electron, yes.
Somebody argued that if you have one photon of so much energy, more than the frequency or threshold frequency, then it can give energy to other electrons also. It does not.
Oh, okay.
It gives energy only to one electron, and that electron utilizes the balance energy. The balance energy is not used to be, given to the other electrons for their emission. No, they need a separate photon.
No, the
So,
balance energy is the kinetic energy.
yes,
अच्छा,
it
ठीक
is
है.
not used for emission of other electrons. So
ठीक है.
intensity plays a role. If you have higher intensity,
Yeah.
more electrons will come out, provided
Hmm.
you have that bare minimum frequency called as threshold frequency.
Okay.
Got
ठीक
it?
है. Yeah.
Any doubts in your mind?
No.
Okay. Now, what did Einstein say? We will come to the instantaneous part. Okay. Just
Yeah.
wait.
Okay.
Okay. So, what was Einstein explanation? And this is the math of it. What did
ठीक
Einstein
है.
do? Okay. So, he noticed all the observations and he created an equation. Okay. Which we will study now. So, this is what he created from that observation of Hertz. Hertz did the experiment. Okay. Here is the observation. Okay.
Yeah.
Now, what he did was he picked up the concept of quantization of light. It means that light is made up of photons, but
Yeah.
packets of photon. Okay.
Okay. Yeah.
And the energy of a photon is
Hmm.
always a multiple of h,
Okay. ठीक है.
Planck's constant. Who
Yeah.
gave this equation? Max Planck.
Yeah.
Right? So
Yeah.
frequency can be anything, but it will always be multiple of h.
ठीक
The
है.
fact that energy is always a multiple of h is called as quantization.
अच्छा.
Like you have principal quantum number,
Yeah.
azimuthal quantum number, stuff like that, right? So all of that is quantization.
Okay.
Angular momentum of an electron which is rotating around a nucleus is mvr is equal to nh by 2 pi.
हाँ. Yeah.
It is always a multiple of n.
Yeah.
Whenever something is multiple of n and depends on some multiple, we say it is quantized
Okay.
because
ठीक है.
it has to have those values, otherwise it will not have.
Right. Yes.
You cannot have a photon which is not a multiple, whose energy is not a multiple of h. Okay. Now,
ठीक है.
so he used this concept. He used Max Planck's equation, which was to do with the quantization of light. So Max Planck theorized that light is quantized and its energy is made because of photons, and the energy level is always because of the multiple of h. So this was quantization of light. Anyway, so he picked up this concept and he said when the photon strikes the metal, now Einstein work starts. He used quantization of light. He said the photon strikes, it transfers the energy to an electron. If the photon's energy exceeds the work function of the metal, what is the work function of a metal? The energy you calculate when the frequency is minimum, the threshold frequency.
Yeah.
Okay. E is equal to h mu threshold is the minimum energy. In short, it is known as work function of the metal. So he said that the photon's energy, if the photon's energy exceeds the work function of the metal, then you will see the electrons getting emitted. It will come out. Yeah, emitted or ejected is a better word. It's not emission. It is actually ejection, right? It just comes out. Now he said the balance of the energy, where will it go? It will go towards the kinetic energy of the. So this is the balance, right?
Yeah.
This is what you gave. This got used to take out the electron called as work function. The balance is the kinetic energy. This is the equation which is called as the photoelectric effect equation. And this is the end of your photoelectric effect understanding too. If you know this equation, largely you understand the photoelectric effect. Okay. Now I will come in detail. We will do the numericals and all of that. Okay. So there will be variations, small changes which are happening. Now this is typical board like, right? So what is the application of photoelectric effect? Board mein aate, you get these questions, right? Use of the answer is photoelectric cells. So nowadays you see solar panels all around. It's the solar panels are using photoelectric cells, and the energy which is getting generated is with the help of radiation.
अच्छा, okay.
Solar radiation, right?
ठीक है.
lot of these doors and light meters are there. Doors are basically, when I say doors, these are, if a thief enters your house, the alarm starts ringing, right?
Yes, yes.
Automatic doors use this.
Yeah. अच्छा,
Okay? So
okay.
it's made, what they use is a photoelectric effect cell inside it. So cell is available, called as photoelectric effect cell. It works when it gets the ray of light from a radiation. If somebody cuts the ray of the light, an alarm bell will go.
अच्छा, okay.
Okay, so the cell used is photoelectric cell.
ठीक है. Yeah.
Okay.
Yeah.
All right. So if somebody says, okay, what is the significance of photoelectric effect? We already know that. It was a crucial evidence for the particle nature of light.
Yes, right.
So you had already studied the wave nature of radiation from interference, diffraction, but now you also, and polarization.
Yes.
Polarization also is a wave nature. Electric field, plane, electric field is a wave and all that, right? So the significance is it complemented the wave nature. Wave nature we already knew.
Yes.
Now we have to complement it, we are saying there is also something called as a photoelectric effect, which is more to do with particle nature of radiation.
Yeah.
Right? So this experiment has a lot of contribution to the wave particle duality.
अच्छा, okay.
And wave particle duality actually is taught in later classes as part of a topic called as quantum mechanics. You will hear people talking some pictures and movies and all that. Quantum physics I like.
Right.
So all these concepts get used later in advanced studies of physics and engineering.
Yeah.
Right? So this is your Einstein. So Einstein gave that explanation of kinetic energy of E is equal to h nu minus phi.
Yes, yeah.
Okay, so he actually went on to write this equation based on the observations of Hertz.
Okay.
The key observations, the instantaneous emission. Okay, the emission of electron when due to only threshold frequencies. What is the effect of frequency? What is the effect of intensity? Okay, all those experiments were being done and noted, but no justification was available to you. But Einstein came, he wrote the equation, he explained it.
Right.
Okay. Now let's come to one more important point. Why the instantaneous emission has been put as an observation. Even if the electron is delayed or it comes out instantaneously, right? What exactly are we trying to convey? Right? That is why is it so important?
Yeah, right.
Okay. Now assume that there is a time delay for the electron to absorb sufficient energy, which means it takes time to absorb, and after some time the electron comes out. So it is not instantaneous. Assume.
Okay.
So now the photon has come. The electron takes time to absorb sufficient energy from the light wave to escape. Right?
Yeah.
But reality is it's an instantaneous thing. A photoelectric effect, right, is a instantaneous in nature.
Yeah.
You strike, it comes out.
Yes.
Right?
Yeah.
Now, the reason of this is that there is a pure wave theory, which is taught in class 11 with the help of that transverse waves, standing waves.
Acha, yeah.
And we have also studied in these things, interference, polarization, diffraction.
Yeah.
Okay, as part of the radiation acting like a wave. But that classical wave theory, what it said was that if you get into details of classical wave theory, which you're not supposed to get into that, but what it said was that our prediction is that if light is a wave, if you want to prove light is a wave, then we say that light would accumulate gradually.
Okay.
Over time,
Yeah.
before the electron gains enough energy to escape.
अच्छा, ओके
That is
ओके।
what those scientists said.
अच्छा, ठीक
Because
है।
they were completely inspired by classical wave theory.
हम्म
Classical wave theory said that any emission, anything that happens takes time. Energy takes time to absorb. It's a
या
gradual process, right?
अच्छा
They applied the
या
same concept on this type of emission of electron,
ठीक है।
which is happening in a photoelectric. And so they said it takes time. But
अच्छा या
and if they were right,
हम्म
then the what would have happened is that the Einstein's photon theory
हम्म
would have no answer to that.
ओके, अच्छा ठीक है।
Einstein had no explanation for that.
ओके।
Fortunately, what was observed was the instantaneous, right?
अच्छा
So
या
the instantaneous emission
हम्म
is also a validation of Einstein's photon theory.
ओके, ठीक है या राइट
Einstein said,
या
this is the equation. In this equation, there is no word called as instantaneous.
या राइट राइट
If there was uh, a word like instantaneous mentioned in the key observations, people will challenge Einstein and say, you have not taken into the slow accumulation of the energy by the
या
electron.
राइट या
So Einstein was right, 100% that. So if the electron actually took a lot of time to come out, Einstein has no reasoning for that.
अच्छा ओके
His equation doesn't say anything whether the energy is
या
being
राइट
absorbed or the
या
ejection is instantaneous or not.
या
Fortunately, this equation is for an instantaneous emission
अच्छा
because in the equation there is no mention of time delay.
या
Nothing is there. So people did ask him, "Ki you are wrong." He said, "No, you apply the photon, the electron will come out instantaneously. I don't need to show any time delay in my equation."
अच्छा
Right?
ठीक
The
या
fact that instantaneous emission is happening was useful to Einstein to say that my theory is right. My equation
अच्छा
is right.
यस
Only this you need to know. Who
ठीक
was
है
challenging him? The people from the world of classical wave theory.
या
This is more than enough for you for a reasoning question. You
ठीक
don't
है
need to know anything more than this. Okay, there
ओके
are many details. This is enough.
ओके या
Got it? Okay.
या
So I will give you some MCQs now
या
on photoelectric effect, and it'll help you find out if you have understood everything. If not, we will correct it.
ओके
Okay, so you try and answer them. See if you have retained anything. All right. So question number 1 for you. All right.
both नहीं
Read it carefully.
increase
Take your
the
time.
frequency of the light beyond नहीं
The number of electrons. The number of electrons.
both 2 and 3
Okay. So let's discuss second, right?
Yeah.
Intensity is everything to do with number of photons.
Yes, right.
More intensity means more photons.
Yeah.
And if the photons are above the threshold frequency, they will generate, each photon will generate an electron. Right?
Yes.
So if you increase the intensity, which means if you increase the number of photons, we'll have more number of electrons. We have already said that it is above the threshold frequency.
Yeah, right.
So and now if you decrease the work function of the metal, the only thing that gets impacted because of this is the work function is that now the photon uses energy in a different manner, which means it uses less energy for extraction. So you have supplied a photon of energy h nu. The work function is this much.
Yeah.
The balance is kinetic energy.
Yes.
Now what you do, you have the same photon and the work function became half.
Oh, yes.
It's a different metal.
Hmm.
So the kinetic energy is going to go up because now your balance is very high.
Yeah.
Only a small part has been used for extracting, right? In this
Yes.
equation, there is no mention of number of electrons. Only thing is the kinetic energy of the electron has gone up.
Yes.
Right?
Yeah.
So then if you want the number of electrons to increase, it is only related to intensity. If you want the kinetic energy, then you change these things.
But like जैसे work function अगर decrease हुआ, तो like जो energy
Balance
लगती
energy will go to the kinetic energy, not towards
अच्छा
increasing the
yeah,
number of
okay.
electrons.
ठीक है.
Make sense or
Yes, makes
confused?
sense.
Okay. Next. Have this logic inside you.
ठीक है.
Word is intensity. Okay, it is number. So number is not mentioned anywhere in the Einstein equation anywhere. Change anything in the Einstein equation, number can only be made to 0 by decreasing the frequency below the threshold frequency. No electron will be seen there.
ठीक है. First one.
Explain. Light source. Okay, so this is quantization. It is a work function. Which statement is true about the emitted? Yes.
So सारे equations में से यही
Of
वाला.
course. Yeah. This is the Einstein photoelectric effect equation.
Yeah.
Fine. No problem. Okay. Good answer.
So it doubles.
Okay. So you are doubling the frequency. And what you want is the kinetic energy of the, So if you double the frequency, the kinetic energy will double.
Yes.
It is directly proportional.
Yeah.
This is what is happening. So you have the photon of this level striking a metal and giving you KE1, right? Now
Yeah.
you're doubling the frequency, that means 2h mu.
Oh, yes.
Amount of energy you need to get rid of the electron, that means ejection of electron is still the same.
Yeah.
It is fixed for a metal.
Yes.
Right? But what about the balance energy? So
Yeah.
yes, kinetic energy is directly dependent on the
Frequency.
proportional to the frequency.
Yeah.
Yes. Makes sense. Okay. So gradually you will grasp it, don't worry. Okay.
So 1 and 3 both. Fourth one.
Yes, the electron happens, right?
Yes.
And classical theory has no explanation. Okay, yeah. Yeah, so emission of electrons is instantaneous, yes. Yes. This can only be explained by the modern wave theory, which is called as the quantum wave theory. Quantum physics. You don't need to know about quantum, you know. Both are in, correct. Okay. This will also help you absorb the concept.
Yeah, right.
Actually, the questioning is in a manner that helps you to confirm that you've learned it. All
Yeah.
right. So let's go for the next. All right. Next question for you.
Planck's constant. थर्ड और फोर्थ दोनों नहीं होने चाहिए.
Sorry. What's your answer?
Planck's constant.
I think it does influence the kinetic energy.
Like, but constant नहीं होता.
No, it's a constant. But if you see the equation of Einstein, he said the kinetic energy is given by h
अच्छा.
nu minus phi. So if you change h, kinetic energy will change.
अच्छा.
Although it's
Intensity
a
का.
constant. Yeah, it's a constant, but it is part of the equation.
Okay, ठीक है. Second वाला फिर.
Yes, that is most important to understand. The difference between intensity and frequency. What is the impact of intensity? Number of electrons coming out.
Yeah.
What is the impact of frequency? Kinetic energy of the
Kinetic
electron.
energy.
If you
Yes.
get this, you can answer probably everything, including graphs.
Okay. Yeah. Uh, Fourth, the metal emits more electrons.
That is correct. This is very nice, right? Perfect.
तो थर्ड वाला तो नहीं होगा ना, मतलब ऐसा तो नहीं है.
I think you should have mentioned electrons are emitted when energy is equal to work function. This is just quantization, right?
Yeah.
This has nothing to do with, there is no word like work function is equal to h nu. What does this mean? That is no
Yeah.
statement.
Right.
It's an incomplete, just to confuse people, that's all.
ठीक है.
Not a real. Okay. You may have to solve the numerical, right? And decide. Okay. So I hope you know this, that one electron E is equal to h nu gives you answer in joules, okay? To convert it into electron volts, what you do is that 1.6 into 10 raised to power minus 19 joules are equal to 1 electron volt.
Yeah.
So 1 joule is equal to these many electron volts.
Yeah.
Right? So if you're given joules, x joules, these many electron volts. To convert the joules into electron volts, divide it with this charge of the electron.
Yeah.
If you calculate using this, for example. I will just tell you how to go about it, okay? And this is an important tip for you to do it quickly. Don't do it, just wait, okay? Do it like this always. If you want to calculate energy in electron volts,
Yeah.
and you're doing calculation of E is equal to h nu.
Hmm.
which
Yeah.
is E is equal to hc by lambda,
Yeah. Let's
because
see.
frequency is c by lambda, right?
Yes. Yes.
Okay. What's a smarter way to do this is
Hmm.
this. So you will do this.
Hmm.
H is fixed, velocity of
Yeah.
light is fixed, right? You don't need to do this, and then you will divide it with the 1.6 into 10, etc., right? Don't do that. Straight away calculate the energy of the photon using
Hmm.
1240 divided by lambda in nanometer.
H into C like पहले कर लिया.
Yes.
Yeah. Okay.
And convert it to electron volts also. Done,
Yeah.
right? But ensure that lambda is in nanometer, and you will get a EV answers, because Einstein is not in joules, it is electron volts. Now, work function is this 2.2 electron volts.
Hmm.
But h nu will come out in joule then.
अच्छा.
Then you first you will calculate hc, then convert it into joules. Instead, use this short trick. 1240 divided by the wavelength in nanometer.
Yes.
Is it? So you converted in nanometers? Okay.
Nanometers में दिया हुआ है.
अच्छा दिया ही हुआ, ठीक है.
Hmm.
So now you have a direct 4.1.
Yeah.
ठीक है, works 4.1. So 4.1 electron volt is the energy of the photon which comes and strikes. Right.
4.1 minus 4.
Good trick, right? It saves you so much time.
Yeah.
Okay. Now go and see the choices. Go, गाने गा. Sing. Sing in English though.
First one.
That is correct. Short and sweet.
Yeah.
Who taught you physics early?
Earlier. सर आते थे like
Okay.
11th.
Okay. Do you feel any difference from that?
A lot, yes.
Okay. Clarity? More clarity now?
मतलब लाइक वो क्या करते थे सर डेरिवेशंस वगैरह करवा दी और फिर डायरेक्टली क्वेश्चंस अब ऐसा समझाते नहीं थे.
Okay. Which means less clarity, right?
Yeah.
Okay. It's a very conventional way of teaching, right? बिल्कुल when school teacher teaches that, right? Derivation.
Yeah.
No focus on concept building or explanations. Anyway, if you have to teach 70, 80 people in the class, what do you do?
Right.
Follow a certain pattern which is easiest,
Yeah.
and you use the same pattern everywhere. I don't teach her that way. Anyway, everybody has their own way. Anyway, chalo ji. Karo, do this.
सर आंसर तो थर्ड है बट लाइक इतना क्लियर नहीं है क्यों होगा.
Okay, let's discuss. Sorry, you know the. Okay, so it says, why does the increasing above not increase, right? This is because the frequency is basically the energy of the photon.
Yeah.
Okay? The increase in frequency will definitely increase the energy of the photon. But one photon can emit only one electron.
Yeah,
Right?
right.
And the balance energy is used as a kinetic energy.
Yeah.
Right? So higher energy does not mean more intensity.
Yeah,
Higher
right.
energy does not mean more intensity.
Intensity, yes.
Right? So increasing the frequency of light will have no impact on number of electrons emitted.
Yeah.
Because it is not intensity.
Yeah.
One photon can emit only one.
Yeah.
This is wrong. This is wrong. This is
हाँ,
outrightly wrong. Each photon does not interact with the.
लेकिन ये थर्ड नहीं हुआ तो फिर तो कोई
Let me
लाइक
just see. I did not read third. The number of photons. So its number of photons decreases with increasing the frequency of the number of photons per unit area has nothing to do with if you increase the frequency for a given intensity, the number of photons don't go down.
अच्छा
Okay, higher the work function of the material changes. No.
no
Wait. But why does no? This is not the reason.
yeah
Work function of the metal. How will the material change? Yeah, material will
right
remain the same.
हाँ
Okay, so if you are increasing the frequency, what will happen? Each photon, no, sorry,
yeah
cannot.
no
Higher frequency photons have lower energy.
no
Sorry, this is outright wrong.
yeah
Now
right
that C3 is the only choice. The
yeah
number of photons per unit decreases with increasing frequency of. If you increase the frequency of for a given intensity means that number of photons. If number of photons is fixed for a given frequency, but if you increase the photons, the number of per unit area. It's not just number of photons, it is per unit area.
yeah
Okay, but let me just. Yes, third is right. That if you increase the frequency, you're increasing the energy per photon, but increasing the frequency will also lead to photon count per unit area basis. So he's linking increasing the frequency with intensity somehow. We have not studied anything like this in.
yeah right
Where did we study this? Intensity is everything to do with the number of photons. Okay, got it. Okay, so we can prove it mathematically, okay, because we did not do the formula of intensity. Okay, let's do the formula of intensity. Then we will get the point here, the product, because I is constant had a meaning here. Okay, so it was given like this. So intensity, let's do an explanation of intensity, what it is. Okay. All right. So the intensity of light basically means the total energy delivered per unit area per unit time. Is basically calculated as the total energy of the photons divided by meter square divided by per second, and is generally calculated as watts per meter.
अच्छा ठीक है
Joule per second. Joule comes from photons, energy. Okay. So if
yeah
you have n number of photons, each having one energy of E, the total intensity of light on your surface is Ne.
yeah ठीक
N
है
is a number of the
photons
photons.
per
E
unit
is the
time
energy of the single photon. Now, what you have done is you have fixed the intensity in the question. You say for a constant intensity. Intensity is constant.
yeah
But what are you doing to E? You are increasing the energy of the photon by increasing the frequency.
Yeah, right.
If I is to be kept constant, the question,
Yeah.
if you keep I constant, what is the only way left to keep the I constant? If you are increasing this, but this still remains constant, N has to go down.
Oh, yeah, right. Yes.
So for a constant intensity situation, if you increase the energy of the photon, which indirectly is increasing the frequency of the photon,
Yeah.
you will end up reducing the number of photons,
Number of
but
photons.
only for constant intensity.
Yeah, taken. Right.
Right? So we did not study this earlier. Okay, so this is the consequence.
Taken. Yeah.
For a given intensity,
Hmm.
higher frequency means we know this.
Yeah.
But if you keep the total energy same, then beam will have lesser number of photons
Yeah. Yeah.
to compensate for increase in energy of single. Clear?
Yeah, clear.
All right.
So failed to load.
I am creating a next page.
So will be failed to load.
Just give me 1 second.
Yeah, now it's there. Nitrogen. A is true, but R is false. Third.
It has come now?
So third, A is true, R is false.
Assertion. That is correct.
Hmm.
Now you know the difference clearly.
Yeah.
Okay. Let's go to the next one.
Both A and R are false. Fourth.
Let me see. You're saying both are. I think this statement is false, right? That intensity has something to do with threshold. It does not.
Yeah. Yeah.
But the kinetic energy is completely dependent on frequency. We've already studied this. Kinetic energy is dependent on frequency.
But like फिर work function वगैरह भी तो
I think we studied, right? Work function for a metal is fixed.
constant, yeah, fixed.
So if you double the frequency, we studied that kinetic energy also doubles. Our conclusion was kinetic energy depends on frequency.
बट लाइक पीछे का ऐसा क्वेश्चन था ना, उसमें तो लाइक कहा था कि वर्क फंक्शन और लाइक प्लैंक्स कांस्टेंट भी कंसीडर करेंगे.
No, that is something else. There is nothing like a Planck's constant here, right?
अच्छा, okay.
There is a Planck's constant in this. Where do you see? Nothing, no mention.
Yeah.
This is a reason is a true statement. Third is a correct.
Yeah. ठीक है.
Statement is correct.
Yeah.
So it's not an explanation. So we have not selected that it is a wrong or a right explanation.
ठीक है. Second.
The photoelectric supports, yes, it does. The energy depends on the energy of emitted electrons. Why second? But though both are true, but R is not a correct explanation.
Yeah.
The photoelectric effect. I think he has explained the photoelectric effect in statement 2. Why is it not a correct explanation? The photoelectric effect itself is an evidence of the particle nature, right?
Yeah.
The second statement is a statement of photoelectric effect.
अच्छा.
No, I'm asking you. I'm not telling you.
Okay.
Discussing with you. I'm not answering. I don't know. I'm just saying, why did you say that?
लाइक मेरे हिसाब से तो नहीं है, एक्सप्लेनेशन नहीं होगा.
Which is fine, but why? I mean, it's not a correct explanation, right? It is.
Yeah.
You're saying it's not a correct explanation, though it is correct. Okay. Now.
एक में तो एक वो पार्टिकल नेचर की बात कर रहे हैं, लाइक सेकंड में तो सिर्फ एनर्जी.
हाँ. So now the second statement is all about frequency, right?
Yeah.
Frequency and kinetic energy, right?
हाँ.
But it also tells you one thing.
क्या?
It tells you that the light energy is being transferred to the electron with the help of photons.
Yes.
That is what photoelectric effect is, right? That the light energy, which is photons, are being transferred discretely, which means one photon, one electron concept. Right? So when I say frequency of the light, I mean the photon. right?
Yeah.
Photon's energy is being given to the electrons
Mm.
to emit for emission, right?
Yeah.
And how is that possible? Because photons are particles.
Yeah.
Think like that. Don't think like equation.
Ach-
Photoelectric effect, what happens? The photon, actually, if you say this in plain English,
Yeah.
you will say photon transfers energy to the electron. Electron comes out and the balance energy goes to kinetic energy.
Yeah.
Plain English, right?
Hmm.
I will tell you then, aren't you saying that photon is able to give energy to the electron because photon is a particle, it's a packet, right?
Yeah.
This is the subtle meaning of this equation.
Acha. Okay.
You saw it mathematical, right?
Yeah. Yeah.
But if you read between the lines, he's saying
Hmm.
that the photon is a particle and therefore photon is supplying energy to the electron because
Okay.
it is particle.
ठीक है.
So the correct answer is A.
अच्छा. ठीक है.
It's an evidence of this, it's a same statement being written. So this is a general statement. And this is a mathematical form, right?
Yeah.
But they are one and the same thing. This is more of a general wave particle nature. But this is also wave part. This is second statement is made possible only because of the wave particle.
Yeah.
Right? If it is not a particle, this second equation is wrong. So the second equation without writing also conveys a message that I am a particle. I
अच्छा.
can I can strike a electron
Hmm.
because I'm a particle. I can have collision.
Yeah. ठीक है. So both A and R are true, and R is the correct explanation. One.
Yes. These are straight away the equations of photoelectric effect, statements of photoelectric effect.
Yeah.
They are. photoelectric current basically is all the electrons that are generated are attracted by a positive plate.
अच्छा.
All the electrons start going in the same direction. Attracted by the positive plate.
अच्छा.
That is called as a
Photoelectric.
photoelectric current. Using electrons of photoelectric experiment as current. But I think the question is all about intensity.
Yeah.
Photoelectric current obviously is dependent on the
Intensity.
Yeah, because you have more electrons, more current.
Yeah. So A is true, but R is false.
I think R is correct. If you increase the number of photons,
But sir,
you
उसमें
will get.
above the threshold frequency होता है.
No, that is understood.
अच्छा.
Okay, it is given that हो रहा है वो. It's happening. Maybe the sentence looks incomplete, but reality is if you increase the intensity, the electron count, provided yes, threshold is over, does increase, right?
तो second वाला फिर.
Well, I think the first is correct, right?
Why?
If you increase the intensity, electrons will go up.
Yes.
If the electrons go up, the photoelectric effect current will go up.
Okay. Yeah.
He's saying, I say current increases because the intensity of light increased.
Yeah.
That is my observation. Somebody says, my argument is because if you increase the intensity of light, you get more electrons. That is why your current is increasing. Yes, true?
Yeah.
Very much true. Very true, right? यही तो होता है. This is what I...
Yeah, right. First.
Let me read the kinetic. Yes, because it depends on frequency, so it depends on wavelength. The wavelength, that is correct. Einstein equation.
Yeah.
Okay. So I'm giving you a case study and then MCQs with that, okay? All the points about photoelectric effect. Okay. I will just copy paragraph by paragraph, ठीक है?
ठीक है.
Okay. You will have all the answers actually in the case study, but you also have the knowledge of photoelectric effect, so it should not be tough for you. This is your case study. Yeah, some part of it. Let me then Copy. The observations. We can read simultaneously the paragraphs. This is the second paragraph.
Hmm.
You want to enlarge it, enlarge it. I will put it on right hand side. Okay. Then the equations. So the equation. Question number 1. This can also come, right? Any case study.
Yeah.
Same thing, MCQs now case study format.
Frequency of light.
Simple.
Hmm.
You don't need to know the case study because case study has the answers, but you already know most of the stuff.
Yeah.
Question number 2 that can come to you.
It doubles.
No. Actually, it doesn't double. We say it doubles,
Sure.
but it increases, but does not necessarily. It is close to doubling,
Okay.
but not doubling. The reason is if you write an equation like this, for example, right? So if you have this h nu is given to be 4 electron volts.
Mm-hmm.
Okay. Why we are saying 4 electron volts, and this is work function is 1 electron volt,
Hmm.
and this is your Ke, right?
Hmm.
So Ke is equal to how much?
3.
Okay. Now I double the frequency, right?
Hmm.
This will remain V.
Hmm.
I will calculate now the new kinetic energy. How much is it?
So,
Is
like
it double
double.
exactly?
No.
No, but it is almost double, right? So it's a rough value double.
अच्छा ठीक है.
But actually it is not exactly, it is not. It's a rough value.
Hmm.
So he was very, very precise in asking this.
Yeah.
Not necessary double, yes. If you had said what approximately how many times does it become? Roughly double. If you travel roughly 3, but not necessarily equal to 3, around 3.
Yeah.
Okay. Instantly. Okay.
Hmm.
So evidence of why it is the evidence of the particle nature of light, because photons are packets, right?
Yeah.
And if the photons are packets of light,
2 and
the
3.
light gets I think this instantaneous emission,
Hmm.
which supported Einstein,
Hmm.
that light is that equation,
Hmm.
his equation, is also a contributory factor
Yeah. So both
towards
2
the,
and 3.
I think this anyway is, right?
Yeah.
So 2 and 3. 2 and 3.
Hmm.
So this completes your conceptual understanding of photoelectric effect concepts.
Yeah.
In the next class, we will do numericals
Okay.
and graphs of photoelectric effect.
ठीक है.
Please go back and again revise and give it a good reading.
ठीक
So
है.
that if you have some good mid reading, read it. Otherwise, your choice.
ठीक है. Okay.
Yes, if you come prepared for the next class, it will be easier for you. But you will be able to do the numericals very easily because your concept is going to be strong. So
Like
just
कोई टॉपिक भी रीड करना है?
हाँ?
मतलब इसके अलावा कोई और टॉपिक भी रीड करना है?
No, that's just this.
अच्छा, ठीक है.
Because we're going to do numericals on photoelectric effect followed by the. So a lot of students will say intensity ka we don't know what is intensity. How do I tell you a graph?
अच्छा.
How do I tell you a graph if you don't know the photoelectric effect equation?
Yeah.
It is good to have good grounding. Otherwise, you will
ठीक है.
get lost in the numerical and the graphs.
Yeah. All right.
Okay? So go back and revise.
Okay.